Okay, hopefully in this video I don't make quite so many mistakes. I apologize very much so for all the mistakes I'm making, but hopefully I've rallied and we can do a little better in this video. Okay, so in this video we're going to talk about other trig equations, so ones that have a few small tricks that we kind of have to do some substitutions and that sort of thing. I did want to go over one more problem from 7.4. So this is the last problem for 7.4, and it's the problem 5 times the sine of theta times the cosine of theta plus 4 cosine of theta equals 0. So if you'll notice on this problem, I have sine times cosine and cosine. This is similar, I'm trying to like relate it back to algebra that you know. So this is kind of like if I had like 5xy plus x. I could pull out an x from both of them and I'm left with 5y plus 1. Technically, we can't solve that with algebra because it's two different variables, but we can this one. It's kind of similar to that. So notice I have cosine here for both of these, so I can pull out a cosine theta. So if I pull out a cosine theta, that's the GCF. I'm left with 5 sine theta plus 4. And then again, I have two factors. I can set both factors equal to 0, so I get cosine of theta equals 0. And 5 sine of theta plus 4 equals 0. When I go to solve cosine theta, I'm trying to figure out where is an x value equal to 0. Well, x value is equal to 0 here at, x value is equal to 0 on bottom and on top. So at pi over 2 and at 3 pi over 2. Okay, so theta equals pi over 2 and 3 pi over 2. So when I write those as my answer, it's going to be pi over 2 plus 2k pi and 3 pi over 2 plus 2k pi. Okay, and k is an integer also, obviously. Here, when I solve this equation, I am subtracting 4 from both sides, dividing by 5. So I get sine equals negative 4/5. Subtracted 4 divided by 5. Okay, so this is one I have to use my calculator for. I hope you went back and watched the other video that I posted. Have a little clarification using your calculator. Just a reminder, sine is going to give me answers in quadrants 1 and 4. I have to find the equivalent answers in quadrant 2 and 3. So when I find the inverse sine of negative 4 over 5, I get negative 0.93 as my answer. So negative 0.93. Remember, sine gives me answers in quadrant 1 and 4. This is obviously the quadrant 4 answer. I now need to find the other one that's in either quadrant 2 or 3. So like this is one of my answers. So one of my answers would be, so this is like theta equals all of this. So negative 0.93 plus 2k pi. I need to find this other answer. So there's 1, 2, 3. I need to find like my fourth set of things that gives me answers here. So I'm going to kind of use my unit circle. So this is a y value of negative 0.8. This is going to be about right here. So this right here is negative 0.93 is that angle right there. I need to find the other angle that's going to give me a negative y value. Sine negative y value would also be down here in this quadrant. So there's a couple ways you can do it. Essentially, the idea here is this right here is also 0.93, like that piece right there. So I need to do all of this plus that. So it's going to be, this is pi plus 0.93. So pi plus 0.93 would give me, let's see, pi plus 0.93 gives me 4.07. And that's what this angle right here, starting right here. This angle right here, pi plus 0.93 is the 4.07. So that's my other set of angles here is 4.07 plus 2k pi. So it's Still infinitely many solutions, like that in itself is infinitely many solutions, but there's 4 parts on your unit circle that gives you the answer of 0 when you plug it in for theta. Okay, so that was the hardest problem from the last time, 7-4. But we're gonna take this and I'm gonna show you like a few like little tricks, and when the equations start getting a little bit weird, ways we can make them a little bit easier. Okay, so our first problem I want to do is, let me turn the page over. Let me get a new page. Let's do the problem 1 plus sine of theta plus 2 cosine squared theta. Okay, so if you'll notice, this kind of looks like one of the problems we've already done where we factored earlier. Let me find it in our notes from the previous video. It looks very similar to this problem. The difference is here I could factor it because I had cosine squared and cosine. Here I have cosine squared and just sine. So that kind of creates an issue, but I also have some identities that I can help me out with this. So cosine squared I know is equal to 1 minus sine squared, so I'm going to plug in that. So I know that cosine squared equals 1 minus sine squared, so let me plug in 1 minus sine squared for cosine squared. So I get 1 plus sine of theta equals 2 times 1 minus sine squared theta. So when I distribute, I get 1 plus sine theta equals 2 minus 2 sine squared theta. Now I have all sine, a sine squared and a sine. So let me move this all over to this side so that I can factor it. So if I move this one over, I get positive 2 sine squared theta plus sine theta, and then subtract 2, and I get minus 1 equals 0. So essentially this is similar to the equation like 2x squared plus x minus 1. When I go to factor that, I get 2x and x, positive 1, positive 2, negative 1. Yeah, that's what it factors into, and then I can set both of them equal to 0. So that means this factors into 2 sine theta minus 1 times sine theta plus 1. Set both of those equal to 0 and solve. So 2 sine theta minus 1 equals 0. Sine theta plus 1 equals 0. When I solve this, add 1 divided by 2, I get sine of theta equals 1/2. This is on your unit circle, where on your unit circle does the y value equal 1/2, pi over 6, 5 pi over 6. So theta equals pi over 6 and 5 pi over 6. Again, I have to write all the solutions here. So pi over 6 plus 2k pi, 5 pi over 6 plus 2k pi. For this one, subtract 1, excuse me, from both sides, and I get sine of theta equals negative 1. Where does my y value equal negative 1? Well, there is only one spot on your unit circle where y value equals negative 1, and that's at 3 pi over 2. So theta is 3 pi over 2, and that's my other answer, 3 pi over 2 plus 2k pi, and just a reminder, k is an integer. And that's my answers. Okay, so from this point down was all old stuff from the previous section. The new thing is just trying to get this equation into something that you can solve. So sometimes you can use, if you have a sine and a cosine squared, or reverse, same thing, if it was cosine and sine squared, use one of your Pythagorean identities to substitute. Okay, let's look at another one. If I had the problem sine 2 theta minus cosine theta equals 0. Okay, so the issue here is not the 2 theta. It's okay to have a number by theta, and you'll see we'll do some problems like that by itself later on. The problem here is the fact that I have sine and cosine, and I can't have sine and cosine and be able to solve it with this problem. Okay, so I need to substitute something. I don't really have anything to substitute for cosine theta just by itself, so let's see if I have something to substitute for sine of 2 theta that gets it in terms of cosine. So this is our double angle formulas. If you'll notice, sine of 2x is 2 sine x cosine x. So in this case, sine of 2 theta is 2 sine theta cosine theta. So that's what I'm going to substitute here. So I get 2 sine theta cosine theta minus cosine theta equals 0. And now if you'll notice, this kind of looks like the problem we did at the beginning of this video. I have cosine here and cosine here. That's like a greatest common factor that I can pull out. So I have cosine theta times 2. So what's left over from the first piece is 2 sine theta minus 1. Set both pieces equal to 0 and solve. So I get cosine of theta equals 0 and 2 sine theta minus 1 equals 0. Cosine of theta equals 0, that is, where does my x value equal 0? X value equals 0 at the top and the bottom, pi over 2, 3 pi over 2. And you'll probably notice once we get down to this point, this is like we're doing these problems over and over and over again. So if you already did this problem once on your homework, go back and look and see what you got for the answer there and just use the same thing. Double check and make sure it's right though. So we said this was pi over 2 and 3 pi over 2. So that gives me part of my answers. Pi over 2 plus 2k pi. 3 pi over 2 plus 2k pi. This one, add 1, divide by 2, I get sine of theta equals 1/2. I've answered this one multiple times. Didn't we just do it on the last problem also? It's pi over 6 and 5 pi over 6. So it's pi over 6 plus 2k pi, 5 pi over 6 plus 2k pi. And all of those are your solutions. Okay, so let's do this problem. If I have cosine theta plus 1 equals sine theta. When I go to solve this, let's go ahead and solve it in the interval 0 to 2 pi. So going in the interval 0 to 2 pi, basically I'm not adding my 2k pi at the end. This will give me just one period of all my solutions. Okay, so if you look at this, cosine, sine, there's nothing I can do to combine them. I can't factor anything out. So like you're kind of stuck at this point. This also isn't squared and squared, so I can't really like replace this sine squared with a 1 minus cosine or whatever. So what I could do here, so that I can do what I just said, so that I can replace sine squared with 1 minus cosine squared or vice versa, instead what I can do is, why don't I square both sides? You're allowed to square both sides of an equation if you want to. Like a similar problem that you might want to do this in is if you have like the equation, I'm making this up, the square root of 2x plus 4 equals 5, I don't know. You would want to square both sides to get rid of the square root. The big thing you have to remember here, you may have forgotten it, but when you square something, sometimes you have extraneous solutions. And the way you check those is you have to check your answers. Extraneous solutions mean they work in the squared version, but when you plug them back into the original equation with the square root, they don't work. So you just have to check your answers and make sure they work at the end, essentially. So we'll have to remember to do that at the end, check your answers, and make sure they work. So when I go to square this, the right-hand side square is easy. It's just sine squared theta. Here, to square a binomial, I have to, essentially I'm going to do cosine theta plus 1 times cosine theta plus 1, and when you multiply it all out, you get cosine squared theta plus 2 cosine theta plus 1. Over here, this is just sine squared theta. Okay, now, excuse me, things are looking better. Let me replace sine squared theta with my Pythagorean identity. Sine squared theta is 1 minus cosine squared theta. So I'm going to replace this. So I get cosine squared theta plus 2 cosine theta plus 1 equals 1 minus cosine squared theta. Now I can move everything over to one side. So I'm going to add cosine squared theta to both sides. Subtract 1. And I get 2 cosine squared theta plus 2 cosine theta equals 0. And factoring this, since there's just two terms, you're going to take out the greatest common factor. The greatest common factor is 2 cosine theta, and left over is a cosine theta plus 1. You now need to set each piece equal to 0 and solve. So I should have started on a new sheet of paper, but that's okay. When you set each piece equal to 0 and solve, here 2 cosine theta equals 0 and cosine theta plus 1 equals 0. When I divide by 2 here, I just get cosine theta still equals 0. So where is my x value equal to 0 on my unit circle? Pi over 2, 3 pi over 2 is where my x value is 0. So cosine of theta, theta is pi over 2 and 3 pi over 2. Remember, we don't have to do the 2k pi this time because we're only doing the answers in one period. Over here, subtract 1. Cosine of theta equals -1. Where is my x value equal to -1? I only have one place, and it's at pi. So theta equals pi. Okay, so I have 3 answers here. Again, we didn't have to do the plus 2k pi thing here because I'm only writing my answers in one period. But remember, because of extraneous solutions, I got to check my answers. So let's plug in these 3 answers into my original problem and see which ones work. So my original problem, this is the checking part. If I had cosine of theta plus 1 equals sine of theta, does cosine of pi over 2 plus 1 equal sine of pi over 2? Well, cosine of pi over 2 equals, let's see, cosine is 0. So 0 plus 1. Sine of pi over 2 is positive 1. That's true. So pi over 2 works. Oh, I'm sorry, you can't see that very well. I plugged in pi over 2 into my original function, and that works. When I plug in 3 pi over 2, cosine of 3 pi over 2 plus 1, does that equal to sine of 3 pi over 2? Well, cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is -1. Does 0 plus 1 equal -1? No, it doesn't. So 3 pi over 2 does not work. It is not a solution for this. And let's try pi. Cosine of pi plus 1, does that equal sine of pi? Cosine of pi is -1. Sine of pi is 0, and -1 plus 1 equals 0. So my answer is just pi over 2 and pi here, not the 3 pi over 2. That's an extraneous solution. Okay, so let's move on to, I have 2 more problems we're going to do. I kind of mentioned here, if you had a 2 theta, it's okay. You can work that out and still get your answer with that. And let's do a couple problems of that. So if I had the problem, this is number 4, 2 sine of 3 theta minus 1 equals 0. I can solve this the same exact way I solve if this wasn't a 3. I can still add 1 divided by 2. The idea here is I get sine of 3 theta equals, add 1 divided by 2, 1/2. And then the idea is like before I had just theta equals, sine of theta equals 1/2, and so I get theta equals my answers. The idea here is my answer 3 theta equals, where is my sine function equal to 1/2? Well, my y values are at pi over 6 and 5 pi over 6. So 3 theta equals pi over 6 plus 2k pi. And 3 theta equals 5 pi over 6 plus 2k pi. Okay, so I still need to solve for theta. So now you just divide everything by 3. So divide by 3, divide by 3, divide by 3, divide by 3. It's kind of weird, but I get pi over 6 divided by 3. If pi over 6 divided by 3 is like doing pi over 6 times 1/3, which would be pi over 18. Okay, so I get pi over 18 here, plus 2k pi divided by 3 is just 2k pi divided by 3. For this one, when I divide by 3, 5 pi over 6 divided by 3, same thing, would be 5 pi over 18 plus 2k pi divided by 3. And that's my answer. Okay, so same idea, it's just you basically, whatever's on the inside, if it was 3 pi, if it was pi divided by 2, you solve it at the end. Okay. The last thing I do want to show you here for this one is, what if after you got this, what if for part B it said find solutions in the interval 0 to 2 pi. So to find the solutions in the interval 0 to 2 pi, I need to figure out what numbers I need to plug in for k so that I get all my answers out in one period. Okay. Before, for the other problem, we just didn't add the 2k pi, but here it's divided by 3, so I can't just not add that. I actually still have to do it. So the idea here is, what do I have to add for k until I start getting things that are too big? So if k equals 0, I'm not adding anything to it. Obviously, that's going to fit in there. If k equals 1, that's adding 2 times 1, which is 2, adding 2 pi over 3 to something. If I added 2 pi over 3 to something, I'm still within my one period going around. Okay, so I can add 0. I can add the k value of 1. If I add the k value of 2, I get 2 times 2 is 4 pi over 3. 4 pi over 3 probably will still be in there. Okay, so adding something plus this much would just be a little bit more. Okay, so I can still add that. If I added 3, if I did a 3 here, that would be 2 times 3 is 6. 6 pi over 3 equals 2 pi. I'm going to be past, like this is not including 2 pi, so I'm going to be past it, so I can't use that one. So I just need to figure out when k equals 0, 1, and 2. Okay, so when you plug that in, when k equals 0, 1, and 2, so let's start off with k equals 0. K equals 0, this would be just pi over 18. So my answer would just be pi over 18, because I'm not adding anything, and 5 pi over 18, because I'm not adding anything there. When k equals 1, it's pi over 18 plus 2 pi over 3. Pi over 18 plus 2 pi over 3 is, if you use your calculator, you can do it that way. So this is like basically adding 1/18 plus 2/3 gives you 13/18, so it's 13 pi over 18. Same thing here, 5 pi over 18 plus 2 pi over 3 would give me 17 pi over 18. Okay, and 17 pi over 18 is still like in quadrant 2, so we're still within that one revolution of the unit circle. And then same thing for k equals 2. When I plug in 2, pi over 18 plus 4 pi over 3, I get 25 pi over 18. When I plug into here, 5 pi over 18 plus 4 pi over 3 gives me 29 pi over 18. So these are my 6 solutions in one revolution. Okay, so this is like as hard as it gets right here. If you're struggling with this, I hope that you will maybe watch the video again, see the other videos that I post, make sure you're doing your homework, but just know like this is the hardest. This is like as hard as it gets right here. So I'm not gonna like make this much harder from this point out. Okay, if you have any questions, please feel free to email me and I'll get back to you as soon as I can.